So like I said, this was similar to one of the problems on the test, or at least a part of the problem, and that is you had to factor this. How does that factor? What times what? Two binomials.
X plus 4, X plus 4.
X plus 4 and X plus 4. And on the test, you really needed to write it as X plus 4 squared to do the problem that you had involving the square root. Now, when you have a trinomial that factors into the square of a binomial, then we give that a special name. We call it a perfect square trinomial. So this is a perfect square trinomial. Right there. And we're going to work with that a little bit. We're going to need some of the skills here to solve the very last problem we're going to work on in this section. But for now, kind of another example of that would be something like this. How about x squared? We'll do plus 14x plus 49. How could I rewrite this one?
X plus 7 squared.
X plus 7 squared. So that's another perfect square trinomial. And what you might start to get is a little bit of an idea of how to go from here to here. In order for something to be a perfect square trinomial, this has to be a perfect square, and this term has to line up just right. So let's see how and what makes those things line up just right by maybe multiplying something out. So let's look at this, x plus, say, 6 squared, which is x plus 6 times x plus 6. And then when we FOIL that out, you're going to get x squared plus 6x plus 6x again plus 36. And notice what happens. You get that 6 added in here twice. So x squared plus 12x plus 36. Now when you go backwards, you're going to say, all right, well, how did this come about? What did I square to get this? One of the things you're going to do is look at the 12 and say, all right, well, if this is a perfect square, two things got to line up. First of all, half of this has to be this, and this squared has to be that. So all these little things have to line up. And let me show you what it's going to amount to for us in this class, what you can expect from me exactly. And that is, our goal is to be able to fill in the blanks for something like this. X squared minus 10x plus blank equals something blank. Our goal is to fill in these two things, or this one, to make it a perfect square and then factor it. So our goal is to fill in the blanks to make this a factored perfect square. And maybe I should put perfect square trinomial. So a good question is, well, how do I do that? How do I figure out those numbers? And the answer is kind of by looking backwards. You're going to start out with something like this, just these two terms. You're going to have to figure out, well, I need a 36 here, and I need the x plus 6 here. So let's look at it this way. To complete the square, and we're going to complete the square on something like this, x squared plus bx plus c, or plus something equals something squared. We're going to have to fill in those two blanks. The first thing that you're going to do is you're going to multiply b by 1/2. 1/2 times b. Now I know there's a temptation with a lot of you to just divide by 2. It's the same thing. And there's nothing wrong with that. It's just that when it comes time to working with fractions for b, it's easier to multiply by 1/2 than it is to divide by 2. The second thing is you're going to square your result from 1. Square the result from the first part. And that would be 1/2 b squared. So 2 steps, exactly 2 steps to get what we need here. Now the 1/2 b squared term, that's going to go right there. And then over here, that term's going to go there. I'm going to have 1/2 b squared. 1/2 b like that. But this by itself, if I squared it, isn't going to give me this. You need the x in here. So it's going to be x plus 1/2 b squared. This might end up being negative because it's going to depend on the problem. But those are the 2 general steps that we're going to follow to try and complete the square on this. Okay, so let's see some actual examples of this to try and make sense out of it, because right now maybe it doesn't make a whole lot of sense. So let's do some examples. Let's start out with this. We'll call this example B. And I'll do a lot of different parts for example B. Start out with x squared plus 16x plus something equals something squared. So we got to come up with those 2 somethings. Fill in the 2 blanks. So what can we do? Well, let's follow along with what I just suggested. We're going to start out by taking half of something. Half of what number? What are we going to start with? Half of 16. Good. So half of 16. Half of 16 is 8. Good deal. And then what do I do with the 8? Square it. So we're going to square that 8. Now 8 squared, of course, is 64. I don't think we need a calculator on that one. That 64 goes right here. Well, what goes over here? Well, the 8 goes here. But it's not enough just to have an 8 there, because 8 squared gives you 64. You don't get the rest of this. What's the correct binomial going to be for this one?
X plus 8.
X plus 8. Nice. And that's it. That's all there is to that one. Now there's going to be 3 levels of difficulty in working with these types of problems. This is the easiest part. Let's try some more here. Before I go on from this step, are you okay with what we filled in and how? Thank you. So let's try a slightly harder one. X squared minus 5x plus something. And it's always going to be a plus something here, like that. Well, even though this is a negative number and a negative odd number, we're still going to do the same trick that we did just a minute ago. And that is, I'm going to multiply the middle number by 1/2. Now maybe it'll be a little bit easier for you if you write that as negative 5 over 1. So what would I get?
2.5.
Let's leave it as a fraction though. All right, negative 5/2, thank you. So that's the first part. What do I do with the negative 5/2? Square it. Yeah, square it. So negative 5/2 squared. Now when you square it, when you square a when you square a negative number, you get a positive number. So it's going to be positive, what's 5 squared?
25.
Over 4. So the 25 and the 4, those are your two magic numbers. So that one's going to go here. So 25 over 4. And then, let's see, this one goes here. But what am I going to put in here to make this all work? X
Minus 5 over 2.
minus 5 over 2. Awesome. But that looks kind of weird. It's like, does that really actually work? I mean, are these two things actually equal? Can anyone suggest a way I can check it? You know, other than asking the instructor, did I get it right? What else could you do? Foil it. Nice. So let's check it by foiling it. So we'll check. So that's going to be x minus 5 over 2 times x minus 5 over 2. First terms, x squared. How about the outside terms? What do I get?
25.
Minus 5 over 2 times x. It's kind of funny, in my morning class, I checked 3 people in a row and they all left out this x. This is an interesting coincidence. How about the last terms? Negative 5 halves times negative 5 halves gives me,
5 over 4.
well, 5 times 5 would be 25. 2 times 2 would be 4. What happens when I add negative 5 halves plus negative 5 halves? What do I get?
Negative 5.
Negative 10 halves, which is 5.
Negative 10 halves, which is 5. Nice. So, great, it checks. X squared minus 5x plus 25 over 4. So before you hand in the test, or if you're doing the review and I don't have an answer for that particular problem, you can check your answer by foiling it out. And it works. Perfect. So that's the medium level of difficulty. Let's bump it up one more step. Comments on this one before I move on to the next one? Sterling, doing okay there? All right, thank you, sir. Let's try this one. X squared minus, you want a really hard one or a modestly hard one?
Really hard.
Really hard one? All right, let's do 2/5 x plus something equals something squared. So let's see if we can't fill in the results there. It's the same 2 steps that we've done in the previous couple problems. So give yourself a shot at that. If you're watching this on video later, you can fast forward until the pause button is removed.
denominator, 2 times 5 is 10. Or you can cancel 2 and 2 at once. So it's up to you. So we gotta do the 2 steps that we've done with the previous step. You just got in. In general, that's the 2 steps. Make it look easier.
Okay. So I'll give you a couple varieties of the first part. You can do 1/2 times -2/5 and get -2/10. But then -2/10 in lowest terms would be -1/5. Another way you can get that, and maybe it's a comfort zone thing, it's up to you, but you can cancel the 2 here and the 2 here, and that would leave you just with -1/5. One way or another, it's probably easier to work with the term in lowest, or excuse me, the fraction in lowest terms rather than having something like this. So let's take our -1/5 and square it. That's going to be 1/25. The 1/25 goes where?
To the C spot.
Yeah, to the C spot. So that's going to come up here, 1/25. And then, Hussein, what's this second term look like?
X minus 1/5.
X minus 1/5. Hey, that's it. Nice. Do you want to do a couple more like this to practice? Maybe 3 quick ones? All right, let's bang these out. 3 more. Easy, medium, hard. And when you get down to the last one, make sure that you, I would suggest that you simplify the fraction before you finish squaring it or start squaring it. But that's, a you choice. When you're doing these, please use fractions. That's typically the way I like these things answered.
That's fine. What's your horse's name? Enzo. Where'd you get it from? Where'd you get the name from?
It's a Ferrari.
Cool. Where is it stabled at?
He's in Red Lake. It's a really nice area out there. The barn's beautiful.
I got a vague notion where is
It's west about 45 minutes.
okay. Down 96. The 81 goes here. These signs should always match. start off by taking half of the middle number. Half of negative 18 is what? 9. That's the first step. Second step, square. That's going to be 9 squared. So that's going to come up here. And here, you don't want 9x minus 9x, because that would be negative 8x. You just want x minus 9. So you gotta get rid of that x there.
Want another minute, or are we good? Another minute? Okay, all right. Sure. All right, let's bang out a couple of these, particularly the easy one to start with. So half of the middle term is negative 9. Negative 9 squared is 81. Both of these terms are going to get used when I fill in the rest of this stuff. So the 81 goes here, so plus 81. And the negative 9 helps us out here. You're going to get x minus 9. So great. You use both of those numbers. Don't just give me minus 9. That would be wrong. Minus 9 squared is 81. You need the x minus 9 to get the whole thing. All right, let's try the next one. So we're going to start out by taking half of the middle number, half of negative 9. If it makes it easier on you, write it as negative 9 over 1. Half of that would give you negative 9 over 2. I like fractions rather than decimals. You could do these things with decimals. It's just, you know, be nice to your instructor. Give me fractions, please. Carvel, what am I going to get when I square negative 9 over 2?
81 over 4.
Perfect. Square the numerator, square the denominator. Squaring a negative number is going to give you a positive number. Jameson, how's this going to fill in?
81 over 4 is in the C spot.
All right, 81 over 4 in the C spot. I like that. Good deal. And then
And then x minus 9 halves.
perfect. X minus 9 halves. I appreciate you giving me that X in particular. Great. The hard one is down here, and that's because we've got this fraction of 8/11. For myself, when I do these things, you know, I try to make my life easier. I'll cross out the 2 goes into 2 once, and 2 goes into 8 4 times. So what's that leave me with?
4 over 11.
4 over 11. 4 over 11 squared is 16 over 121. If you're not fraction friendly, then take out a calculator. Nothing wrong with that. In fact, I can make it real easy. Let's do a half times 8 over 11. But I'm going to get lazy. Instead of typing in 1 divided by 2, I'm just going to type in 0.5 times 8 divided by 11. Now I'm going to get a hot mess out of all this. But do you remember how to make this a little bit more intelligible?
Math, enter, enter.
Yeah, math, enter, enter. There you go, 4/11. And if you wanted to, hit the square button from here. Bam, there you go, 16 over 121. Pretty nice. So you've got everything you need there. Let's fill it in. As before, this goes here. So 16 over 121. And then x plus 4 over 11. And as before, if you wanted to, you could FOIL this out to check that when you square this, you get this. Sweet. Oh, there goes my ride. Okay. Comments on this one? You're comfortable with these? I mean, this is probably, 2 points, 3 points, 4 points. It's a 9-point question on an exam. So it's exactly what to expect. If you have some questions or you're struggling at home, get some help on those things. Let's move on. I'll call this one example D. Example D, we're going to start out with kind of a nice one. X squared equals 25. Now you could solve this quadratic equation by factoring. You could go x squared minus 25. I wouldn't copy this down. It factors because it's the difference of squares. What two solutions do I get here?
X equals 5 and x equals -5.
Good. X equals 5 and x equals -5. But in this section, we're going to solve this a little bit different. We're going to want to take a shortcut on this. Nick, you look like you've got an idea here. What shortcut could I take here?
The square root of both sides.
Yeah, take the square root on both sides. But Lauren, when I take the square root on both sides, I only get one answer. I get x equals 5. I know there's 2. How could I fix it?
If you go plus minus.
Yeah, excellent. Let's do a plus and a minus. So that this is really representing x is plus 5 or x is minus 5. Now, just giving you a heads up on WebAssign, you're probably going to have to list the answers. So on WebAssign, it's probably going to look like this, 5, -5. I don't think they're plus minus friendly like I am. On an exam, hey, that's fine. That's a good Jeff answer. On WebAssign, you're probably going to have to break it up into a couple of little spots like that. Okay, so with that idea, let's talk about things in general. In general, when you have, if x squared equals b, then you can take the square root on both sides. You're going to get x equals plus or minus the square root of b. There's 2 solutions there. Please don't miss out on one of them. I need both. If you just give me one solution and I'm expecting 2, that's more than a point off. All right, that's missing something important. That's 2 points off. Probably. I don't think it'll be meaner than that, but I want you to give me both of those. So let's keep going with a few examples here. This is still all part of example D. X squared minus 36, kind of a friendly one to warm up with. As before, you could factor this, but I'm really hoping you won't factor this. When your quadratic equation is missing that middle term, then let's use the square root property. So it's x squared equals what?
36.
36. What does x equal?
Plus or minus 6.
Plus or minus 6. Thank you. Nice. Well, that was too easy. Let me get meaner. What if I did y squared minus 31 equals 0? Could I still do the same thing here?
Yeah. No.
Well, we'll see. Let's put the 31 on the other side. Y squared equals 31. And then what?
Take the square root plus or minus.
Take the square root on both sides, right? So let's see here. 31. Let's actually write it all out. So square root here, square root here. Actually, I need the square there. Don't forget the plus or minus. And y is going to equal, well, there's not much I can do with the square root of 31. It's just the square root of 31. It's 5 something, right?
If you could, would you factor?
Great question. The answer is yes. And let's see that with this next example. What if I had say b squared minus 24 equals 0. So I get b squared equals 24, b equals plus or minus square root of 24. But somebody asked a good question here. Bonus points, making me look good, thank you. If you could factor, should you? And the answer is yes. So John, help me out here. I need a perfect square that goes into 24 evenly.
4 and 6.
Yeah. 4 is our perfect square. 4 goes in there 6 times, so the final answer is plus or minus 2 square roots of 6. Well done, thank you. Again, notice we're not forgetting that plus or minus. It has to be part of all of our work here. Let's try another one. And that is 3x squared minus 16 equals 0. How would you start on this one? Any suggestions? What can we do to start the
Yeah.
move the 16 over? Ian, help with that?
5 by 3.
You can do either one. We'll get to the same spot, and now you'll see where we're going to get to the same spot. So for myself, I would move the 16 over and then divide by 3. You could divide by 3 right here. 3x squared minus 16 equals 0. Divide everything by 3. And I think you're going to see that it works out the same way. Here I get x squared minus 16 over 3 equals 0. And then guess what? Move that to the other side. So it gets to the same place. Thank you, gentlemen. But now that I'm here, what do I want to do?
Square root is next.
Yeah, take the square root on both sides. Wonderful, thank you. Square root on both sides. Now, what am I missing?
Plus or minus.
Plus or minus. You need that plus or minus as you do these things. So, got the plus or minus here. Can anyone simplify that a little bit for me?
4 over square root of 3.
All right, so it's plus or minus is still out here. We're going to break this up into the square root of the numerator and the square root of the denominator. So it's going to be plus or minus 4 over the square root of 3. You may remember from the last chapter that I don't really particularly care for irrational numbers in the denominator. So how can I get rid of this square root of 3 here?
Square root 0, square root 3.
Perfect. Thank you, Colby. Multiply by root 3 over root 3. And we get plus or minus 4 square roots of 3 over the square root of 9. But the square root of 9 is 3. So that's what I'd be looking for. I think this is what WebAssign will be looking for. They might take this. I don't know. Take your chances if you like. Let me know if they do. I think they probably should take that, unless they say in the instructions, rationalize your denominators. But I'd be a little surprised about that.
Test-wise, would you want us to answer with the,
You know, on the last test, it wasn't exactly like this, but there was some problems that I accepted this kind of ish stuff. But if you did this, you got an extra credit point. So I appreciate when you're thorough and conscientious in your answers beyond what I asked for. Just be careful you don't go too far and do something that's wrong. But I do appreciate that. I'll point out a little bit later. I think it's in the next section where we actually do something that you could get an extra bonus point, or at least on the last test you did. All right. I think you got a pretty good groove on some of these things. So let's mix it up a little bit. Let's try about p squared equals -4. we even solve this one?
Yeah.
What should we do?
Imaginary.
But what should we do in steps in terms of solving it? What should we do?
Square root of both sides.
Yeah, we take the square root on both sides. Just because you got a negative number here doesn't really bother us too much. Mel, what am I missing from the right-hand side? Plus or minus. We always need that plus or minus. The square root of p squared is
P.
p. And as far as square root of negative 4 is concerned, I guess one way to handle this is to write it as the square root of 4 times the square root of negative 1. How does that simplify?
2i.
2 times I. Nice. So building on the stuff that we just did. Nice. So this is why we introduced I a little while ago, is because it works out pretty nice. If I wanted to check it, how could I check it? How could I prove that I got it right other than saying, "Psst, Mr. Instructor, how did I get it right? Did I get it right?" What could you do to show you got this right?
Square root of both sides. Or square both sides.
How about if we plug this back in for P, right? So let's square it and see if I get negative 4. So that'd be 2i squared, which is 2i times 2i. What's 2i times 2i going to give me?
4.
4i squared. And what's I squared equal to?
Negative 1.
Negative 1. 4 times negative 1 is negative 4. So, wow. That works. What if I had negative 2i? Would that make a difference? Not really, because when you square negative 2i, what's negative 2 times negative 2? It's still positive 4. So both the positive and negative solutions would work in this case. So, wow, we got a nice little solution here.
Is there a point where we're gonna have to like check if they're extraneous?
It's a great question. For these problems, when you're solving quadratic equations, you're not going to get the extraneous solutions that we did when we were solving radical equations. So, yeah, we're doing a different operation that's not going to result in an extraneous solution. It's a great question. Let's try one last one before I mix it up even further. And that would be m squared plus 96 equals 0. Sarah, start us off. What would you do to get started on this one?
Subtract 96 from both sides.
All right, subtract 96 from both sides. Great. Ryan C., keep us going. What should I do next?
Square root of both sides.
Square root both sides. Thank you.
Plus and minus.
We're missing that plus and minus. Thank you, Mel. So missing the plus and minus. Square root on the left-hand side is going to be m. On the right-hand side, I'm going to want you to split that up into 3 different terms. Can anyone guess what the middle one's going to be?
-1.
-1. Good. And then you got to look through your list of perfect squares and try and find something, Ryan G., that goes into 96 evenly from your list of perfect squares. So, I don't know. How many times does 16 go into 96?
6 times.
6 times. Cool. So this will all simplify. Emmy, what's that going to equal?
4i square root of 6.
Perfect. And that's our answer. 4i times the square root of 6. Beautiful. Beautiful. We should celebrate that one. So copy it down real quick and then we'll celebrate it. Let's see. Here we go. Ready? A little math humor. Oh, come on. How about a little smile? That was kind of cute. All right. Grudging, or your real grudging smile there. All right. Whatever. Plus or minus 4i times the square root of 6. Great. You can check these on your calculator if you wanted to. I mean, you could check it by squaring it and getting this. But just to give you a reminder, you could check it on your calculator. So how would that look? Let's see. First of all, we need to calculate 4i times the square root of 6. So 4, and then remember how to get to the I? Where's the I? Second decimal, square root of 6. And then I'm just going to hit the right arrow to get out from underneath that. And I'm going to store that back in my variable x. And what I want to see is if I square this and add it to 96, do I get 0? So basically I'm treating the x as an m. So let's take this value, x, and then square it, plus 96. Hold your breath, any bets? 0. And if you're just like, well, wait a minute, that doesn't feel right. If you're nervous about that, just do x squared. X squared should equal negative 96, and it does. So you can check these things. I encourage that. Okay, let's keep going. Comments or questions on this one? You're okay with this one? Thumbs up? Yes? All right. Karine? Thank you. Okay. Let's see, we'll call this one example E. What if I had x plus 9 squared equals 64? What would you do on that one? Yeah, take the square root on both sides. So, let's see. X plus 9 squared, 64. So we'll take the square root on both sides. There's my square root on the left-hand side. Here's my square root on the right-hand side. Need that plus or minus. So on the left-hand side, let's see. Pearl, what do I get on the left-hand side?
X plus 9.
X plus 9. On the right-hand side?
8.
Just 8?
Plus or minus.
Yeah, I need that plus or minus 8. Now here's a spot where you have to slow down. You can't move this over here and get plus or minus -1 or something like that. You've gotta slow down. So let's take a look at that. X plus 9 could equal positive 8, or x plus 9 could equal -8. Notice we're changing the 8 on the right-hand side. You're not changing the sign in between these things. So you've got the positive case and the negative case. When you solve these, you're going to do the same thing on both sides. You're going to subtract 9. For the positive case, you get a -1. How about for the negative case? What do we get here? Yeah, well done. -17. Thank you. And that's it. Those are your two solutions. So you got this or this. You could check it by plugging in, say, a -1. Yes?
Is that going to be for WebAssign? Is it going to be just like listing?
Yeah, you know, on WebAssign. So on WebAssign, it's going to be -1, -17. I'm pretty sure you just have to list them. But you know, even for me, you got to have them kind of written out one and the other. It's not like it's plus or minus 6 or something like the last one, plus or minus 4i square roots of 6. You just have to list them. So yeah, going to need to see that. But you can check both of these. -1 plus 9 is 8. 8 squared is 64. Great. Negative 16 plus 9 is negative 8. But when you square negative 8, you get positive 64. So both of those actually check. Now, do you have to check things when you're solving quadratic equations? It's not like our square root equations. You're not going to get an extraneous answer. Was it a good idea to check these things? Yeah, absolutely. Doesn't hurt to make sure you got it right before you hand in the test. All right, so that's kind of like their first glance at that one. Let's try another one. X minus 1 squared equals 81. I'll give you a minute to work on this. Make sure you give me 2 solutions.
Two solutions, right? Positive and negative. Okay, all right, that's cool. It's all right. So it's like minus 1 plus or minus 9. And then you gotta list out both solutions, right? Good. Now write out both possibilities, one and then the other. And then finish solving. Good. Now write out both possibilities.
Okay. So, like a lot of these, in fact, like pretty much all of these, we're going to start out by taking the square root on both sides. So, square root here, square root here. Don't forget that plus or minus. Let's put that here. The square root simplifies pretty nicely. It's going to be x minus 1 equals plus or minus 9. And it's, at this point, you got to slow down. We've got a positive case and a negative case. You have to solve those separately. You can't go, oh, it's plus or minus 10. Sorry, it just doesn't work that way. You get the positive root, x minus 1 equals 9, and x minus 1 equals negative 9. In both cases, you're going to add 1 to both sides to solve. But you're going to get much different numbers on each of these. We'll get x equals 10 or x equals negative 8. Either one will work as a solution. So both of these, or list it with a comma between them if you're solving it on WebAssign. How are we doing on that one? Walked around, most of everyone is working okay on that one. All right, so obviously we're making things too easy. I have to make them more challenging then, right? Okay, let's do that. Let's try a third one, kind of this variety. X plus 7 squared plus 16 equals 0. What did I pick on yet today? It's funny, I never get any volunteers when I ask that. Carvel, where do you think I should start?
Subtract 16 from both sides.
Perfect, thank you, sir. Subtract 16 from both sides. Rachel, what are we going to follow that up with now that I've got x plus 7 squared equals negative 16?
Square root both sides?
Yeah, we'll take the square root on both sides. So square root. Square root. Let's not forget that plus and minus. That's worth a couple points. What do I get when I take the square root on both sides? Ian?
It would be root 4.
You could do it that way. It's making it a little bit harder than you need to. How about if I just do square root of 16 times square root of negative 1? I mean, what you said can work, but it's just you're working harder than you have to. Because we've already got a perfect square here. So how does that simplify? What do I get when I simplify that?
4i.
Yeah, thanks, Sarah. 4i, so plus or minus 4i. There's a little bit of a difference between what we have here and what I had up here. Up here, when I was solving this problem, 1 and 9, those are like terms. I can add those together, so that's why I did those kind of separately and said, oh, okay, you know, x minus 1 equals 9, x minus 1 equals negative 9, and then solved. Can you add 7 and 4i?
No.
Are these like terms? No. So here's what I'll let you get away with. For this class, you're not going to quite get away with it for WebAssign, but if I move that 7 to the other side, what happens to it?
-7.
Thank you. It becomes a -7 plus or minus 4i. Yay. So that's the Jeff answer. Anyone want to suggest what the WebAssign answer is going to be?
-7 plus 4i and -7 minus 4i.
Perfect. -7 plus 4i and -7 minus 4i. You just got to list them out. Takes you an extra 3 seconds. I'll accept that on a test. Keep in mind that if these terms combine, I do want them combined. But if they don't combine, if they're a real number and a complex number, then okay, you don't have to. All right. I'm going to do one last example to accomplish 2 goals here. Before I do, are we okay with completing the square and using the square root property for stuff like this? Good on those? All right, just got a few thumbs up. A couple more, thank you. All right, I don't know if you want to copy down this last example or not, or maybe just kind of take it all in, but let's see, example, where are we at? F. We're actually going to solve a problem by completing the square. Now, it's kind of lengthy, I won't lie. Negative x squared minus 18x plus 17 equals 0. Now, how does that work? What does it look like? Well, I guess it might be nice if I could focus. The left-hand side isn't a nice perfect square, so I'll move that 17 to the right-hand side, and it changes signs when I get there. Okay. But what I want here is a perfect square. So what we're going to do here is we're going to put in a number to make that a perfect square. This is exactly the kind of stuff that we did at the start of this section. If you wind back the tape, I said, all right, we're going to use this to solve the very last problem we're going to do. Here it is. What number do I put here to make this a perfect square trinomial? I want to write it as something squared. What number makes that a perfect square trinomial? John? Almost. No, put it here.
81.
81. So remember, you take 1/2 of negative 18, gives you negative 9. Negative 9 squared gives you 81. So 81 is what I put here. But can I just put 81 on the left-hand side of the equation because I want to? What else do I need to do? Need to put it on the right-hand side of the equation. So, John, here's where your -9 comes in, right down here. So it's gonna be x minus 9 squared equals, well, that's gonna give me 64. That's looking a little bit better. What can I do here? Now that I got that out of the way.
Both sides.
Take the square root on both sides. Thanks to seeing you. So 64, let's take the square root on both sides. Here, square root here. On the left-hand side, I'll additionally take plus or minus, so I get x minus 9 equals plus or minus 8. Nice. So let's solve both equations, because there's really two hidden in here because of the plus or minus. Here's your positive, here's your negative. I get x equals 17 or x equals 1. Okay. And so that's the process of solving a quadratic equation by completing the square. It's not the most efficient way. There is one good thing that you can use this process for, and that's to build a general formula to solve these kind of things in general. So in the next section, we're going to get a formula that solves all this. And it's the way you derive this formula, or the way you can derive, one way you can derive it is by this process. But let me be very clear on something. When you take the test, I'm not going to tell you, oh, you have to solve this one by completing the square, or you can solve this one by factoring, or you can solve this one by the square root property, or the quadratic formula. I'm just going to say solve it. So if you gave me x squared plus or minus 18x plus 17 equals 0, I would do this. I'd factor it. How does it factor?
X minus 17 and x minus 1.
X minus 17 and x minus 1, and there's your two solutions. Wow. So you spend 30 seconds doing it this way, or 5 minutes doing it this way. I know which way I would choose. On the test, if it factors, factor it. If it doesn't, then you're gonna have to figure out something else. But if it factors, go for that. Absolutely. So, comments or questions on that last one there? When you do your WebAssign homework, it's likely to say solve this by completing the square. I mean, if you have to, you have to. But by the time you get around to doing your homework, we're going to learn the quadratic formula for solving these things. I would just use the quadratic formula to solve it if it's not something that factored. If I gave you x squared minus 18x plus 5, then you're stuck using either the quadratic formula or completing the square. But I would just go for the quadratic formula. I don't use completing the square to solve these problems like ever. I do one example just to show you what it's like, but that's it. Okay, let's put this one to rest.